Hello. Oh dear, what a good start. Good morning. Oh dear. I am still very much tired. I don't know what it is, but the last few days I've been sleeping really badly. So, ooh. Okay, hang on. I forgot to put my phone and stuff on silent, so let me deal with that real quick. All right. So yeah, as usual, I'll be sipping my coffee. I just woke up. This is my first coffee. My brain is very much still underpowered at the moment. But we'll get to it. Just as an announcement, so coffee, explore, Dani Crunch, right? So this is my Ko-fi page. For monthly supporters, you can actually get access to the source code of everything that I'm doing on the stream at the moment. That means the GameBoy assembler stuff. As you can see, I have GameBoy Assembler Alpha 2 and Alpha 1 down here. You also get access to all the source code of the YouTube videos, right? I also make announcement about new YouTube videos on here, in case you follow Ko-fi more than anything else. But yeah, I have not put Alpha 3 from Monday's stream on there yet, because I figured I don't really want to share the source code after every single stream, but rather after I achieved a significant milestone, right? And so far, nothing much has changed, right? Actually made the program even more unusable than before, because, you know, I commented out all this tokenizing code just to test the dictionary stuff, right? Which, of course, that's not a real alpha version of an assembler, right? So I want to get a bit further with all the features before I actually release the code as Alpha 3. So probably by today, we will have something that's a bit more release-worthy, let's put it this way, right? So I have a few to-dos here. I added a few to-dos after the stream. Just to recap, in the last stream, what we've added is the dictionary, right? So we have this little dictionary type right here where we put all the strings in there, just in the contiguous memory. And then we perform a linear search over it to then find symbols that are similar to the one the user has typed, right? So if we ever get an unknown symbol in the assembler, we can then perform a linear search over this dictionary and be like, hey, did you by any chance mean this symbol instead, right? Because that is kind of close to what you want. And for that, we have computed the Levenstein distance, right? This spelling kind of... so Stein is usually spelled S-T-E-I-N, right? At least in German. So this SH thing, Stein, it's kind of weird in my brain, you know? But I just call it Levenstein, right? Sorry, this was the one, right? The Levenstein distance. It basically finds the minimum edit distance you need to get from one string to the other, right? Specifically, I have used this Wagner-Fisham algorithm version, right? It's using the Levenstein distance right here, basically, the edit distance. But This seems like the most straightforward way to do it. But I did add a few optimizations into it. So for one, this version right here needs a two-dimensional matrix, right? So you're actually allocating memory for all of this, and then fill up the matrix as you go along, right? But actually, as you're calculating the edit distance, so hang on, before I continue with that, you calculate this matrix, and then you can get the minimum edit distance, which is right here on the bottom right corner, right? So to get from Saturday to Sunday, you have an edit distance of 3. Like that's the minimum amount of steps you need to do to get from that one string to the other. This 2D matrix is really cool because then you can basically walk it backwards to figure out the edit steps needed, right? So here the edit distance is 3, right? And you just look for the minimum in the matrix to know where to go to, and you go up here, right? Because this is the minimum. However, it's still 3, so nothing has changed yet. You go up here, it's still 3, right? Nothing has changed yet. Because, you know, day and day is still the same. Then you go up here, nothing has changed yet, right? But we compare N and R, right? And then you find the minimum here, which will be 2. And with 2, you know, so our edit distance now has decreased by 1, which now means we know that in this step we actually need to change something, right? And what do we need to change? Well, we go diagonally up, and that means change. So going this way means delete, right? Going diagonal means change, so swap one character for another. And going up means insert a character, right? So since we're going from here to here diagonally, we know we need to change a character. And so we just know we need to change R for N or N for R, depending on, you know, what is your source, what is your target. So then we look here, we look for the next minimum, right? It's 2, so nothing really has changed yet. Because the U is the same, right, for both of these words. And then we look for the next minimum, and it's over here. So this over here means delete. So we need to delete a character. In this case, we delete T, right? Cool. So then we have to find another minimum, which is 0, right? So we go over here. We know there's another minimum. This means delete. So we know we need to delete the A, right, to get to S. And then because we reach 0, that is the edit distance done. Like, you can kind of think of it this way. There's probably a better explanation somewhere on how to traverse it backwards. Maybe not. I don't know. In any case, this is kind of cool, and you really need this whole matrix if you want to, you know, kind of print the edit steps. So build the diffing out of it, so you can present it to the user, right? So you can then build like an edit script out of it, tell the user what to remove, what to add, stuff like that. But in my case, for the assembler, hang on, got a sip. So in my case, for the assembler, I don't really need that, right? I'm just trying to find similar words. So this whole 2D matrix is like completely wasted space to me. And in fact, you can boil down this algorithm in just having to store one row, right? And then the previous character that you need. So you don't need this whole 2D matrix, right? So the previous character, because as you traverse, like you're going from left to right here, right? So this is always the same. This is the first row. Same with the first character here. But then as you calculate the edit distance, you just need to compare like the delete, the insert, and the delete, the change, and the insert, and you're just trying to find the minimum out of these three values so you can put it in here. And then you go over to the next and do the comparison with those three values again, right? So all you need really is just one row where you constantly update all the values, and then a previous value which you can compare to. And then you just go on and on and on, right? So that's one thing that I changed. So as you can see here, the edits, they no longer have source length times target length times, whatever this size is. I just instead have like one row. I fill up the one row with like the initial values for that string, and then I calculate over it. And I have this previous value right here, right? It always starts out fresh, and because this is basically just the edit distance, like the default edit distance to get to an empty string, you can just start out with whatever your index is plus 1, right? So for the 0th character, it's 1, 2, 3, 4, 5, and so on, right? Because to get from this to an empty string, you need to delete one character, right? So here you need to delete 2 characters. This is basically how the algorithm starts out. Well, and then I calculate the Levenstein edit distance, right? Basic stuff. And then I go out of it. So that is useful. But then another thing I had was that in this test code right here, I actually wanted only a maximum edit distance, right? For example, if you need like 7 edits to get to, one symbol, then that is not similar enough to the one that the user has typed, so I'm just going to ignore it, right? And before I had this down here, but that means I still had to calculate the whole edit distance, right? So I kind of modified this algorithm to bail out early, essentially. So I specified a max edit distance of 3 right here. And the bailout is fairly simple as well. So the first thing it's doing, it's calculating the difference between the lengths, right, of the strings. So if they're the same length, the difference will be 0, which is fine, right? But if the difference is actually bigger than the max edit distance, then I'm bailing out already. I'm not even allocating memory for the row and then doing the sole algorithm thing, because you have to imagine, like, let's say foo, right? So we're looking for foo, and there is foo, and then 1, 2, 3, 4, right? So 4 characters. So the user has typed in this, and we're trying to see if this is similar. I mean, it kind of is, but it needs 4 edits to actually get there, right? Because you would need to delete 4 characters at least, right? In any case, you need to either delete or insert 4 characters to get to this string, no matter what. So there's no point in actually calculating the edit distance out of it, because you already know you won't be able to reach it, right? Not within your max distance that you specified. So I'm going to bail out early. And then I also modified the algorithm to bail out in here. Because, so if we look in here, here the edit distance is 3, right? But what if the maximum edit distance should only be 2, right? So this bailout doesn't save as much as I thought it would, right? But if we can even like stop, well, that's not true. It actually saves a lot if those 2 words are actually completely different and don't use the same characters, right? If they share a few characters, then this bailout algorithm will probably just bail out 1 row before the last, so you don't need to do the last calculation. It's not much, it's not saving much, right? But if it's all different words, then you might actually bail out on the 4th row already, right? And if you have like a really long symbol name, then That's pretty cool. The way I'm doing this is once I calculated a row, I look for the minimum of the whole row and store that as the minimum. I mean, I'm not doing it after I calculated the whole row, right? I keep a minimum from the beginning. So here the minimum is 1, right? And as I calculate, I see, is this smaller than 1? No, of course not. So is this smaller than 1? No, 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 right? And then on the next row, I have a minimum of 2, right? Because it starts out with a 2. And then I check, is this smaller than 2? No. Is 1 smaller than 2? Yeah, it actually is. So our minimum edit distance is 1, right? And as we continue, it will stay 1. And we go on until we reach, like, let's say our maximum edit distance is 2, right? Then well, bad example. Let's say our maximum edit distance is 1, right? We just want 1 character of difference in similarity. Then this row is still fine because the minimum edit distance is still 1. Now we calculate the next one, and the minimum edit distance of this row is 2. So because we only want a minimum edit distance, a maximum edit distance of 1, we can already bail out because there is no way as we continue with the string to go back to 1 because this row does not have a 1, right? And this is essentially what this is doing. So we have a row minimum, which always starts out with the previous, which, as you remember, is the index plus 1. Right, and as we continue on the x-axis, I just compare the row minimum with the new minimum edit distance that we just calculated. I'm stored this in previous here, but you know. And keep whichever one is smaller, right? And then after we've gone through the whole row, I actually just check, is my row minimum actually now larger than the maximum distance that I want? And if it is, bail out, right? So those are the things I have done to speed up the algorithm a little bit, which is cool, right? But there is a few more things I can do. Okay, I have something here. Store the length of the longest string in the dictionary and do not even iterate over it if the symbol in question is max edit distance longer than the longest string in the dictionary. Right? So what that means is we have a dictionary with symbol names. Let's say our longest symbol name is 5 characters, right? But then we have an unknown symbol that suddenly is 9 characters, right? Then we know, because our max edit distance is 3, right, that we won't find anything in this dictionary for this thing. So we can just not bother looking through it. So that is one thing to do. Another one, well, that's not really perf, but one thing I need to fix. Nah. Let's call this performance and then enhancement. How should I type this? So the max edit distance of 3 is kind of alright for really long strings, right? Because it's kind of similar and you just want 3 edits, that is fine. But as the strings get smaller, right? For example, we have, let's say, our assembler commands, right, are LD and ADC, right? Now, a max edit distance of 3 allows for like, right? You could type LX, and what it would spit out is basically all the assembler commands that are possible, which is, you know, is not correct, right? Shockingly. Because, like, you would just basically print out all the commands. What you really want is LD, right? Instead of LX, and not ADC or bit or whatever. But because the max edit distance is 3, those would perfectly be valid. Well, not quite. But it would, for example, say LDA, right? Because 1, 2, 3. No, it's actually changing. So, yeah. Or let's say we have LDX, right? Then ADC would still count as a max edit distance of 3, right? When in reality what you would want is LDA or LD. Right? But ADC would be printed out because, well, you can change the L to an A, which is 1 edit, right? And then you can change the X to a C, which is the 2nd edit, so 2 edits. So for really short words like this, what you would want is probably a max edit distance of just 1, right? So dynamically adjust the max edit distance based on the string length. Strength with just 2 to 3 characters. Probably only should have a max edit distance of 1 instead of 3. 3, however, should remain the maximum after a certain threshold. Also consider edit distance of 2 for strings in between. Sure, Mr. Lawyer. Okay. Let's open up the old one. Okay, so this is something I need to do later on, right? We got the dictionary of symbols, that is fine. Maybe, let's call it research. Figure out if I should split assembly keywords from other symbol names, right? So, hey, yeah. Figure out if I should split assembly keywords from other symbol names for the dictionary. I should clarify. Otherwise, I will forget what I actually meant by that. Okay. So, but that is for later to figure out. I also will be removing the test thing. So we have a way of adding things to the dictionary, which is good. So I will just be adding stuff from now on. Right. I don't need this anymore. You know what? This thing of storing the string of the longest word in the dictionary is actually something I could just easily do right now, right? Oh, but before I do, what I noticed while I was working on the edit distance stuff is that, oh my lord, sorry, I'm still not fully awake. At the moment, I store the string length as U64, which is kind of insane if you think about it. Like, am I ever gonna have a string that's like, as big as the entire memory that my machine can hold? Certainly not. That would be, frankly, ridiculous. So we might as well just reduce the length to U32, but then maybe set the maximum limit to whatever S32 max is, right? Which would allow for roughly 1 GB of strings in length. If it was UTF-8 encoded in every single character would be 4 bytes long. So plenty of space, right, to convey a lot of information, and I don't need to carry around a U64 for the length. And then that kind of makes this whole edit distance algorithm a little bit easier to reason about. So I will change that, and then, yeah, that seems like a good change to do for the beginning. Change the string length, and then see whatever else it touches, and make sure it's correct. So we change this to U32. This needs to be changed to U32. Format is still okay. That is okay. String format buffer. We're putting that string into a buffer. U32 is fine. Right. This is actually kind of dodgy. I'll show you why. Hang on. Let me just change these to U32, right? Yeah, right here. And right here. Okay, so U32, this is fine. Fine. U32 required length. Yep, this is also fine. I mean, if I make it even more bigger, then I get trouble reading stuff, because I have less on the screen. I bumped it up 1 notch. Is that okay? Maybe. This should be fine as well. Okay, two pixels bigger. How's that? This feels so huge. I feel like I'm a senior now. Hang on. There we go. Okay, we have a required length here, U32, that is fine as well. Then here, that is as well. STB smprintf actually also returns a 32-bit thing, I think. Let me check. Yeah, it's just an int, which, I mean, technically at least 16-bit. Not necessarily 32 bits, but hey. On modern machines, 32 bits. So, okay. Zero termination really necessary here? Yes, let's leave that for now. String equals u32 len, that is fine as well. Right. What we could do is also length is no s32 max is bigger or equal to length. There we go. Probably want the same here. This is fine. I haven't used the copy string anyway, have I? I mean, no harm in keeping it, but you know. Okay, cool. Projects, GB assembler, alpha 3 built. Oh, right, I removed the test thingy. Hang on. Right, let's get rid of the dictionary altogether. Plonk in back our old code. Right, and run. Fantastic, still works. I mean, why wouldn't it? But okay, so one of the things is dodgy because strt, right? We have a string, string literal, right? And let's say it is just empty, right? I suspect it will overflow. Debug. Whoa, that's a lot of tabs. Like, why are you all open? Okay. What about my source view? Oh, it's down here. Why is it down here? Okay, how do I close panels again? Close panel. There we go. Program, right, so let's go. And then we have locals and we have string. Oh no, length is null. Really? Right, it can't do that. Well, okay, apparently it's not a problem. I just don't know how to see. So I thought... Right. Okay, now I'm just confused. Oh, right. You're right. I use size off. You're absolutely right. Thanks. Right. You know, sometimes you do not see... Okay, so size of then probably... Right, that's why I did the -1 in general, because size of also includes the null termination character, which makes sense, right? Because it's taking the size of the entire byte, so that's why. Then just doing -1 to then remove it. Right, okay. So it made sense what I did. I was, yeah. Yeah. It made sense when I wrote it, and then I got confused by it. Fantastic. Like I said in the beginning of the stream, I haven't slept well in the past few days, so I'm a bit... But we'll get through it. We'll get through it. Okay, so this is fine then. Okay, so now I just need to figure out where I use str. Right, so on the console stuff... length is not this. Right, okay, but we need this. Right. The cast to U32 is no longer necessary because, well, guess what? It is a U32 already. Okay, cool. Then in error list, so line, column, and position I probably still want to leave as U64. Column probably, I mean, it could be an insanely long line of text, right? Unlikely, but I think those I leave as U64 for now. No, this is all fine. Then we have hash map, right? Capacity is fine. Every time I refer to like memory locations, I do want to leave it as U64. Who knows? I at one point might have a, I don't know, 16 gigabyte hash map, right? Who the fuck knows? So, if it comes to memory stuff, U64. This can so overflow, by the way, but okay, it's only used in my code for now, so it's fine. It's not like this is a library or anything. Right, string, this is actually now U32 as well, and we have this one right here, right? I mean, the hash is not a U64, it's a U32. Did I really? No, it's a U32. So why? Why oh why? Do I use U64 down here? That's fine. Arena doesn't work with strings, so I do not need to worry about that. IO might potentially work with strings, right? File name. Ah, damn it. Okay, S32 max bigger or equal to file name length. Here we have the code point stuff. Position is right. I mean, that is not working with strings, right? We're actually just returning code points. So that is fine. Dictionary I come to, that's the whole reason why I found out about the length stuff. It made no sense, really. Stats doesn't work with string length either. I mean, it does for string format, but we just fixed that. So tokens, that is fine as well. Yeah. And like I said, dictionary I'll deal with in a second. Okay, cool. So dictionary now. We also want value. I mean, this is okay because we're specifying a memory size, right? So this is all right. Do memcopy, right. Okay, this subscript I think is no longer used. Yeah, I no longer need that because I changed it. Okay, so this length needs to change, and this length needs to change. So source and target. And max distance. Actually, let's do it the same way. Oh my god. Okay, now the difference can be just an S32 as well, where we calculate the difference between those strings so we can bail out early if necessary, right? I wanted to reason about the return values, so let's say define edit distance bailout. Let's define it as, I don't know, it doesn't really matter, does it? -1, whatever. So this is our bailout code. This is still fine with U32. I mean, this is just an arbitrary thing, right? So even though we cannot hold strings in that length in this moment, we're just trying to get an arena of that size. Actually, let's leave this as U64, right? Because it is used for this one. Right, this needs a different error code. So define edit distance allocation. Now, let's just say error, right? I disagree with the more readable part. Yes, I could make macros for that, but not really gonna do that. So different error code than bailing early. Yeah, we got that. Set distances to empty strings, right? That is okay. Set initial edit distance towards to string. So that is a U32. No, actually it isn't. Right. Ah, this is all kinds of annoying. So I used S32 to have negative values being used for errors. But then, because this is 32-bit in length and plus 1, no, that's okay. The largest edit distance will still be S32. So that is fine. Yeah. Yeah, that's fine. That's fine. The only issue comes with these then. What I could do for now, see ya. No, I don't want an assert always in the loop, but I can have an assert in here for now, so in case this ever happens while I debug. Don't think it will. But whatever. Okay, so, and then we have bail again down here, so edit distance bailout, right? I mean, to be fair, I can just have those edits U32s, right? Do that. Just U32s, that's fine. And then I can have the assert in the end for the result. So U32 results. Like this. Then it can be actually an assert always. And make our intentions clear with the cast. Yes, S is for signed. I don't want the full range of U32. And like I said, with S32 max for strings, even if you have 4-byte encoded UTF-8, it's still like, what, a gigabyte worth of characters. So it's fine. And this is going to be fine for at least this assembler, right? It's not like I'm writing a library or anything like that. That's needs to be as general as possible for every use case. Okay, so this makes a bit more sense. Length undeclared identifier. What? Which line? 7, 8. Well, yeah, because it's key length, right? Oh dear. Same on console. And also here. Ah, signed, unsigned mismatch. Okay, what did I miss? Right, that's fine. It cannot be negative anyways because I already checked for that stuff. Okay, cool. Right, so we did this, and we did this. So now we should probably work on tokens and actually recognizing symbols and the parsing stuff, right? So I think it's come to that time. So with the tokens, at the moment I just have read token, right? Which probably is not enough. So really what I need is a similar mechanic that I have in the IO source file stuff, meaning I need a get code point and swallow code point. So basically a peek and then a consume, right? So I kind of want to implement that. Now, token type has the starting position in bytes, and it also has the overall length, right? So you're so lost in the source. Feel free to ask questions. Maybe I can clarify stuff. Do you want me to give you a quick overview? So basically, okay, shoot. I see. Okay. Well, I'm writing an assembler for a GameBoy, right? So basically, we have this source file, and it contains assembly source code, right? And we want to convert this file into a binary ROM file that contains machine instructions, right? So we can then put it on a cartridge and run it on the Game Boy, or just load it on the Game Boy emulator and run it, right? So because this is text, which a computer doesn't really understand, right? You need to convert it into machine instructions. So I'm basically writing a parser for this stuff. So we're going over this character by character, trying to tokenize it, then kind of build a syntax tree out of it, which is what I'll be doing shortly, and then analyze the syntax tree, which in assembly is like fairly simple because there's only a few things you need to be worried about, and then I mean, to be fair, I've never worked on stuff like this before either, so I'm out of my depth as well, but this is how I learn, right? Just try and attempt and do something. Okay, so about Visual Studio Code. I'm not using Visual Studio Code, so maybe someone else in the chat is using it and can help you out, so feel free to ask a question, but I certainly can't. The only thing Visual Studio related is Visual Studio right here, where I have the old version of my assembler, which what I'm converting at the moment, but where do miscellaneous files get stored? Yeah, like I said, I can't. I can't help you there. Okay, so tokens work with code points already, right? So we're consuming code points with this pattern of like picking and then swallowing it if it is valid, right? So after we already get the token, the source file, the pointer to that source file within that data is already at the location for the next one, right? So our token mechanic just basically needs to be read a token, store it somewhere. We can probably just use a global somewhere, keep hold of it, and every time we call get token or get current token or whatever, it just basically always returns the same token. Yeah, probably can do that. I mean, it's not multi-threaded, so just the global for the token is fine. We're not doing anything fancy. So maybe something like get token from this source file. Maybe this is worthwhile doing a tokenizer struct for this, to be honest. To store some information. Okay. So struct tokenizer. Nope. Struct Jesus. Tokenizer. Then we can hold on to the source file, right, for that tokenizer, so I don't need to pass it around all the time. And we do not need arenas or anything fancy like that. And then we can just have a token here. I wonder if it is useful to also hold on to the next token. Because we probably want to peek ahead at some point. Sort of a double buffering thing, right? What do you mean 40 bytes is a lot? Dude, you have 16 gigs on your machine. 40 bytes is nothing. What is this? We're not coding for a GameBoy itself, right? Yeah, I think I keep it like this. I could access those directly, or have some helper methods for it. I'm not quite sure how to do it yet. Um, you also have to keep in mind that a token is very short-lived, right? We only have 2 of them in the entire process while parsing the file, essentially. Why did I do double taps here? Get memory arena buffer, right? Arena, and the size will be size of tokenizer, right? And then we have tokenizer t. Let's call it result. Fine. Okay. I do have to do this because this is not guaranteed to be null. I mean, I might reuse some of the buffers, that's why, but okay. No, so basically I'm just going through the tokens to build a syntax tree out of it, right? So they're very short-lived. And even for the syntax tree stuff, you just need that on a line-by-line basis because this is assembler. yeah, whatever you want to call it, an AST or whatever, but it's not even going to be that complex, honestly. It's going to be very specific to the assembler, and it's like only one line basis because there is no multi-line code in assembler, right? It's fairly straightforward. Actually, I think the amount of information. Have you heard of Jonathan Blow's programming language, Jai? If you look at his tokenizer, he's storing a lot more information per token and is holding on to like 16 tokens at a time or something. So yeah, I wouldn't be worried about that. This could essentially also just be a string already, but this is fine. This is fine. Okay. You know how to get courage of doing something like this? Just go ahead and do it. Don't think about it. Just go ahead. Don't worry about writing the most perfect code or correct code or whatever. Just go ahead and do it. Right? That's what I did with the first iteration of this assembler. And I learned a lot since, and this code is fairly horrible, right? it's like so much wrong with this. This is why I'm doing more or less the rewrite. But yeah, just do it, honestly. Even if you think you do not have the skills to do it, just do it because you will learn the skills on the way. Like, I don't know who exactly gave me that advice in the past, but it's the best advice I've ever gotten. Just do it. It is a rabbit hole for sure. Before I decided to go with the Game Boy stuff, I was actually watching a lot of Ben Eater videos with his 6502 computer. And I was like, I even bought the kit and everything and bought, tried to build it. And I was like, yeah, I'm going to write an assembler for this stuff. But then I was like, okay, I know nearly like nothing about electronics. So it's just focused on what I'm good at. Well, good at, right? Software. So okay, so read next will actually just use read token, I think. So let's just, whoa. Okay, I didn't realize it would do that. Why do you expand when I move you? That's fairly annoying. I just want to move it one line up and down and then it expands the whole code. It's just a bit annoying. Okay, whatever. Maybe read next is slightly misleading. So let's say advance. Right. Basically what we're doing here is tokenizer current token is tokenizer next token, and then we basically just call retoken with tokenizer file and the address of tokenizer next token. That's it. I'm sure it won't stay that way. But for now, it is what it is. So this is the old parser, which, yeah, it's not great. So basically what I think I want is, so we have, right, we go from bytes to code points to tokens, right? I want to transform those tokens into some kind of data structure that gives me the overall syntax for one line of code, right? So syntax line, call it a syntax tree if you want to, I don't know, but it's just for one line anyways. So this probably happens in the parsing step, and then we want to validate that tree, right, to see if it actually syntactically makes sense, and then write the binary. So basically back to bytes. Right, let's say bytes UTF-8. So what do you call something like this? Should I just do it in the parser and then have a validator or something? Or like, I mean, maybe let's just call it syntax. Nah, let's put it in parse. Parse is fine. Parse is fine. GB assembler parser h. Parser h. Right, and then we also have a parser c. And here in main, parsing parser? Oh dear, whatever. It is what it is. Yes, save changes. Let me just clean up a little bit. There's too many files open. It's a bit annoying. Okay. Syntax tree, syntax, a line of code. Let's just call it syntax, whatever. Ah, no. What am I doing? So what do we need? This will be fun. Let's have a look at the assembly file itself, right? So comments and whitespace usually get ignored. I'm not going to worry about this. But essentially, let's start with labels. So labels can pretty much prefix everything, right? You can plonk on labels anywhere you want. At the beginning of anything. Like even in front of an alias, you could say, right, foo. It won't relate to this command though, it will just be, it just marks the position in memory, so actually it will be like whatever, probably the same address as entry point in this case, to be honest. So labels can go anywhere. Label definitions, that is. So that means we kind of have something like, actually, let's open this next to us. So let's say we have a root, right? Actually, we have a root. And from there, we probably have labels, right? And then, yeah, fantastic. But this in C is like a special character, isn't it? Whatever, I won't keep it there anyways. So on the one hand, we have labels. There can be multiple labels, so we can just chain them together, right? Doesn't matter how. So label 1 followed by, label 2 or whatever, how many labels you want. And then on the other hand, so if there's no labels, this pointer would just be empty. Let's put it that way. And well, the next thing basically just is a statement, right? So, or an instruction, an assembly instruction, more or less, right? Even alias or include are kind of instructions. They just have different operands